This is a y. Yes.
Can we go over A?
There's two a's.
Okay.
Okay. So I'm guessing you got to this part, right? 4 to the power of x equals y cubed and didn't know what to do. Cube root. See it? That's it. To undo a power, you take the root of that power. Whatever, I mean, it could be a 37. You just take the 37th root and you're done. Okay. All right. Feeling a little better? Natalie.
Can you do the second 8?
So it's, what is the domain and range? It's a logarithm. What's the range?
All numbers.
All real numbers. The domain, x is greater than h. What's h?
Okay.
0. It's only h if it's in parentheses. Is it in parentheses?
No.
There you go.
And then like for B, do you set the whole thing equal to 0?
B.
X plus 1.
X plus 1 equals 0, so x would be greater than?
-1.
Correct. So you would actually end up moving your entire graph slightly to the left, wouldn't you? Anyone else? Okay, let's look at some properties, all right? Now, I want you to look at the properties in the way that I'm going to explain them, because I told you logarithms aren't numbers, they are exponents. So they behave like exponents, okay? So let's look at the log rules that correspond with the exponent rules. The first rule you have is, this exponent rule is x to the n times x to the b is equal to x to the n plus b power. Are we remembering this rule? Well, if logarithms are to be treated like exponents, then log base b, did I put b on that one? Log base b of mn, recognize that m and n are either variables or constants, or maybe they're just multi-polynomial terms, okay? But they are being multiplied together. This is called the product rule. Our first product rule shows that they added for exponents, so in the same way, logarithms add. Log base b of m minus plus log base b of n. And my first thought as a student would be, so what? Right? Well, watch this. Log base 3 of 6 equals log base 3 of 2 plus log base 3 of 3, because 6 is really 2 times 3. What's log base 3 of 3? So this is really log base 3 of 2 plus 1. This would be considered expanded form, and that would be the solution. If I were to have a base of an exponent equal to a base a base of a logarithm equal to the base inside of the logarithm, which is kind of a tricky thing to think about, but we've been working on this, it ends up being the exponent, okay? When the bases are the same, the answer is the exponent. We've gone over that a bunch of times. That first answer on page 13, I'm sorry, it's log base 5, not log base 3. We have log base 5 of 18 plus log base 5 of 3. When the logarithms are the same and they are being added together, I am really using the product rule. So that would be log base 5 of 54. So that would allow me to use the product rule. The product rule can be used to put things together and take things apart. Okay? This example is not in your notes, but you might want to use it. This would be an interesting one. Log base 6 of 4 plus log base 6 of 9. This is not in your notes. But if I were to put this together using the product rule, the 4 and the 9 would multiply, right? So if the 4 and the 9 are multiplying, that would give me log base 6 of 36. And 36 is what squared? So this is log base 6 of 6 squared. When the bases are the same, the answer is the exponent. So that would have been your answer. So this is why we learn the product rule. Every once in a while, you might end up with something that unifies together and comes up with a basic numerical answer of something we know what to do with. Because logarithms aren't regular numbers, they are dealt with like exponents. The second one you see on part B right there is log base 4 of 22. This problem can be expanded only once. There are times where you can actually expand it multiple. Okay? What are the factors of 22? 11 and 2. So this would be log base 4 of 11 times, plus log base 4 of 2. I really like to put my logarithms in parentheses when I'm dealing with it because it makes it easier for me to see. I recommend you do that as well. Is it necessarily wrong? Well, it's only wrong if you were to have something like log base 4 of x plus 1. Inside parentheses, that's the h value. If there were no parentheses, that would be a k value. So there would be an inherent difference. But other than that, I would generally expect you to use parentheses pretty much all the time. So kind of think about that. All right. Let's go to our next rule. Our next rule seems to be the quotient rule. And the quotient property stems from the idea in exponents, x to the a power minus divided by x to the b power would equal to x to the power of a minus b. So you subtract the exponents. Well, once again, since logarithms are dealt with just like exponents, if I have log base b of m divided by n, that can be rewritten using the quotient rule as log base b of m minus log base b of n. So once again, turning to page 13, you have two quotient rules. One of them you need to combine, and the other one you would need to, it's called expand. So say that word, say expand. First answer, hopefully you got log base 3 of 12 divided by 4, and 12 divided by 4 is? 3. And what does log base 3 of 3 equal? So that answer ended up being 1, which is interesting. Why? Well, just because. That's why we do these things. We can find new values, which is a pretty awesome little characteristic of logarithms. Our second example there is log base 3 of j divided by q, or j over q, as some would say. This is going to be rewritten as a difference problem. Agreed? So it's going to be log base 3 of, what's next? Minus log base 3 of, and there we go. So I have these examples, okay? So on the top left, this is the exponent rule that we can associate with our new logarithm rule. Division means subtraction. Subtraction means division. But we have to be careful because there's some pitfalls. Let me show you a few traps that people get stuck in. All right? So I want to talk about the product rule and the quotient rule, and I want to make sure you know what they don't mean. The log of m plus n is not a product. In fact, this isn't even the product rule, and there's nothing I can do here. I cannot expand this problem at all because the addition is not related to multiplication. The addition is internal to the logarithm. Okay? So when I say internal, that means anything inside that parentheses. If it had been log of mn, then I use my product rule, log of m plus log of n. But this and that are not equal. So please do not interchangeably use them. Okay? The next thing that I want to go over is the division rule. The log of m minus n does not equal the log of m minus the log of n. This is division. That equals the log of m divided by n. That's what this one is. This one is subtract the m and the n before you take the log. There are no rules associated with this subtraction internal of the logarithm. They're only associated when we are actually dividing inside the logarithm. So be very careful, because a lot of people tend to, or a lot of students, as I've noticed in the past, tend to mix these rules up because they see a minus sign, so by seeing the minus sign, their mind reverts, oh, I must divide. It only means divide if it's a logarithm subtracting a logarithm, and the most important part, of the same base. If they don't have the same base, you can't do any of these rules anyway. Next, we have our power rule. And our power rule, in my opinion, is the most enjoyable one of all, because it's the one that tends to help us the most within this area. Okay? So, x to the power of a to the power of b, you multiply the exponents. Well, since logarithms are actually treated like exponents, if I have log base b of m to the power of x, in this case, log base b of m is treated like an exponent, and x is treated like an exponent. The power rule states that I can put the x in the front. X times log base b of m. Well, how does that help us? A while back I told you if the bases are the same, the answer is the... So log base 3 of 3 to the 5th equals 5, because the answer is the exponent. Well, let's use the power rule and demonstrate this another way. That would be 5 log base 3 of 3. What is log base 3 of 3? What's 5 times 1? See how it still validates our original claim that when the bases are the same, the answer is the exponent? So let's look at some examples on page 13. You have two examples right now that we need to kind of cover. And the first one is, so this first example is, 5 log base 7 of 2. To rewrite this, I need to simply take the power rule. What power am I going to be moving? The number we are moving is 5. 5 was the power. 5 is the exponent. 5 is placed out front. It's going to move back to the 2. So this will be rewritten as, I'm sorry, I don't need another 5 right there. It's going to be rewritten as log base 7 of 2 to the power of 5. So once again, you hopefully have noticed that the power rule and the product rule and the quotient rule are interchangeable. I can go forwards and reverse with all of these rules, okay? Your next example is log base 4 of x cubed. Just using the power rule, the basic power rule, what can I do with this 3? Move it out front, which will yield the answer of 3 log base 4 of x. Are these rules only allowed to be used Once in a while. No. Could multiple of these rules happen all at the same time? Sure. So let's look at something real quick. Let's look at some examples that I have here. And the first ones tell me to condense the logarithm. First thing you always check when you're condensing logarithms. Do I have the same base? That answer is? They both seem to have a log base of 2. So I have to use order of operations. What is more important? Addition, subtraction, multiplication, exponents, division, parentheses. Parentheses. Do I have anything in parentheses? No. So now I go to exponents. Are there any exponents? And in my mind, I would say, I don't see any exponents, but there is one. And there's an exponent because of which rule? Power property. The power rule. And the exponent is the 3. So this is an exponent right here, and it needs to be placed with the x first. So I'm going to have log base 2 of x cubed. So I am condensing that first question that asks me to condense. My next property that I'm going to use looks like addition, but because these are exponents, it's really multiplication. So this is the product property. So tell your neighbor what you think your answer should be. And once you've told them, look up and see if you got it right. So, things to note. I don't have a multiplier out front. I also don't have any more plus signs. Everything combined into one thing. So I can condense, meaning bring together, or I can expand. We have one more to condense. I want you to try to condense that one. It's on page 13 in your notes. Once you've condensed that one, look up here and you can check if your answer is correct. So as I already showed, this is the answer here. But the first thing, if you have log base 4 of 26 minus log base 4 of 13 plus 3 log base 4 of 3, I can do these together and that by itself for the moment. So that will be log base 4 of 26 divided by 13, which is log base 4 of 2. The 3 will head and become an exponent based on the power rule. So our first rule was the quotient rule and our second rule was the power rule. 3 cubed is 27. So this is plus log base 4 of 27. Well, this is the product rule. Product rule says if it looks like addition, it must be multiplication. So I multiply 2 and 27 together, and I get the answer of 54. Log base 4 of 54. So that would be what's considered condensing, bringing together. There is another one, and it's called expanding. This example was chosen specifically because it has a weird occurrence in it. Both the x and the 5 seem to be cubed inside of this logarithm. So if I take the power rule, which would move the 3 out front, I would have 3 times log base 2 of x divided by 5. That leaves me with the quotient rule. 3 parentheses log base 2 of x minus log base 2 of 5. That is almost expanded all the way. Now I need to distribute my 3. That would be 3 log base 2 of x minus 3 log base 2 of 5. You could actually start this rule slightly differently, and you could rewrite this as log base 2 of x cubed divided by 5 cubed. And you would end up doing the product, the quotient rule, which is subtraction, and then the power rule, putting the 3 in front of each of them at the end. Either method will return to you that answer. And that's what it means to expand, to break it down into its least component parts. Clear as mud? Good.